Hi students, we have already discussed about the concepts of local maxima and local minima, absolute maxima and absolute minimum. Here we are going to do some problems based on these concepts. When we are considering CBSE board exam, this section is very important. We can expect one sure 6-mark question from this section. Okay, let us do the problem number 11 from exercise 6.5. Look the question. It is given that at x is equal to 1, the function x raised to 4 minus 62x squared plus ax plus 9 attains its maximum value on the interval closed 0 to. Find the value of a. Look, here f of x is x raised to 4 minus 62x squared plus ax plus 9. We know that for a function, if it attains its maximum value, it happens at the critical points or at the end points of the interval. It is given in the question that it is attaining its maximum value at x is equal to 1 and end points of the interval are 0 and 2. Therefore, clearly we can say that x is equal to 1 is a critical point for the function. Therefore, clearly from this it is clear that x is equal to 1 is a critical point. Then we will obtain critical point by putting f dash x is equal to 0. Therefore, we can easily say that f dash 1 is equal to 0. Therefore, f dash 1 is equal to 0. Here f of x is x raised to 4 minus 62x squared plus ax plus 9. Therefore, f dash x is equal to 4x cubed minus 124x plus a. Therefore, f dash 1 is equal to 4 minus 124 plus a. That is equal to a minus 120. We have f dash 1 is equal to 0. Using that, we can write since f dash 1 is equal to 0, it implies a minus 120 is equal to 0, implies the value for a is equal to 120. This is the answer. Next question is question number 13. Find two numbers whose sum is 24 and whose product is as large as possible. We have to find out two numbers and it is given that their sum is 24. We have to find out that numbers in such a way that when we are finding the product, it must be as large as possible. Then we know that because since the sum is 24, it can be 21 plus 3, 22 and 2, 12 and 12, 8 and 16 like that. Here we have to find out the right answer so that the product of that two numbers is as large as possible. Let us do this problem. Let the required numbers be x and y. Given that x plus y is equal to 24. The question is to find out the value for x and y so that the product xy is as large as possible. Therefore, I am going to take that product xy as a function. Let p is equal to xy. Then, here this is the function and we need to find the points which is maximizing this product. And we know that for a function, its maximum or minimum, it happens at the critical points of the function. Therefore, we are going to find the critical point for this function. But before differentiating this, one important thing we must do is try to write this in terms of only one variable. Here p is equal to xy. We can replace y from this. X plus y is equal to 24 as y is equal to 24 minus x. Therefore, p is equal to x into 24 minus x, that is equal to 24x minus x square. And for finding critical point, we need to find dp by dx. dp by dx is equal to 24 minus 2x. And for getting the critical point, we need to equate this dp by dx is equal to 0, implies 24 minus 2x is equal to 0. Then we are getting 24 is equal to 2x, that is x is equal to 12. Now the thing is, we got one critical point. We got one critical point, x is equal to 12. And the critical point can be the point of maxima or the point of minima. For determining that, here we are using the second derivative test. The second derivative test is saying that when the second derivative at the critical point is negative, then that critical point is a point of maxima. If it is positive, then that critical point is a point of minima. Let us see what happens here. Here I am going to find the second derivative. d square p by dx square. The second derivative is equal to minus 2. Therefore, whatever the value of x, here x is equal to 12, the second derivative is less than 0. This implies x is equal to 12 is a point of maxima. We are not using the word local, just we are writing it as a point of maxima. Therefore, we are getting x is equal to 12 as a point of maxima. When x is equal to 12, when x is equal to 12, y is equal to 24 minus x, that is 24 minus 12, again 12. Therefore, the required numbers are 12 and 12 so that the product is as large as possible. Therefore, the required numbers are 12 and 12. Next question is question number 16. Find two positive numbers whose sum is 16 and the sum of whose cubes is minimum. We need to find two values so that the sum of their cubes is minimum. Therefore, it is the expression of the sum of the cubes is to be differentiated. We need to find the critical point of that function. And after getting critical point, we need to check whether it is a point of maxima or minima using second derivative test. Here it is given that the required points, the sum of that required points is 60. We can take that 2 points as x and y. Therefore, it is given that x plus y is equal to 60. Let us take that 2 points as x and y. It is given that their sum is 60. We have to find out the values for x and y, which is minimizing their sum of their cubes. Therefore, we need to differentiate the expression for sum of their cubes. Let us take S as the cube of first number x cube plus the cube of second number y cube. We need to find the value for x and y which is minimizing this expression. And we know that the point of minima that point will be one of the critical point. Therefore, we need to find the critical point of this function. For that, we need to differentiate this. But before differentiating, we need to write this in only one variable. Then look, here x plus y is equal to 16. Therefore, we can write y as 16 minus x. Therefore, our s is equal to x cube plus 16 minus x the whole cube. For finding the critical point, we need to find ds by dx. Derivative of x cube is 3x square plus derivative of 16 minus x the whole cube is 3 into 16 minus x the whole square into derivative of 16 minus x is minus 1. That is, our first order derivative is 3x square minus 3 into 16 minus x the whole square. And for finding the critical point, we have to equate ds by dx is equal to 0. That implies 3x square is equal to 3 into 16 minus x the whole square. You can cancel 3 and 3. Then you are getting x square is equal to 256 minus 32x plus x square. Again we can cancel x square and x square. Then you will get 32x is equal to 256. It implies x is equal to 8. Now we got critical point as x is equal to 8. This point can be the point of maxima or point of minima. For determining that, we are using the second derivative test. Here the first derivative is 3x square minus 3 into 16 minus x the whole square. Therefore, I am going to find the second order derivative. Now, d square s by dx square equal to, differentiating this again, it is 6x minus 3 into 16 minus x the whole square is this 2 into 3 minus 6 into 16 minus x, that's the derivative for the square part, then into derivative of 16 minus x, that is equal to minus 1. Therefore, the second order derivative is equal to 6x plus 6 into 16 minus x. This is the expression for second order derivative. Now what we have to do is substitute the value x is equal to 8 in this second order derivative. Then you are getting 6 into 8 plus 6 into 16 minus 8. Look, 6 into 8 is a positive quantity plus 6 into 16 minus 8. It is again 8. It is 48 plus 48, 96. No, actually no need to find the actual value. We want to know whether it is positive or negative. Here it is positive. Second order derivative is saying that when the second derivative at the critical point is positive, we are getting a point of minima. This implies x is equal to 8 is a point of minima. Therefore, our s is equal to x cube plus y cube will be minima when x is equal to 8. When x is equal to 8, what is y value? When x is equal to 8, y will be 16 minus x. 16 minus 8 is equal to 8. Therefore, the required numbers are 8 and 8, so that the sum of the cubes is minimum. Therefore, required numbers are 8 and 8. So that sum of the cubes is minimum. Next question is question number 17. Actually, from this question we are starting that important 6-mark questions. Question number 17 is saying that a square piece of tin of side 18 cm is to be made into a box without top by cutting a square from each corner and folding up the flaps to form the box. What should be the side of the square to be cut off so that the volume of the box is the maximum possible? We have a square piece of length 18 cm. And from each corner of that piece, we need to cut a square of side, some meters, we don't know what is that, from each corner. And from the remaining portion we are going to form a box without top. Then what should be the side of the square to be cut off so that the volume of the box so formed is as large as possible? This is the question. Now look, this is the square piece. Then we are, from each corner, we are cutting off a square of side x centimeters. Then look, from the using the remaining portion, you just look, it is like this. Using the remaining portion, by folding the flaps, you will get a box without top. Then we need to find what should be that side x so that the volume of the box is as large as possible. Therefore, it is the expression of volume of the box is to be differentiated. Okay, write like this. Let x centimeter be the side of the square to be cut off from each corner from the square piece. Then look, then folding the flaps, you will get a box without top. We need to find out the value for x, which is making the volume of the box so obtained as its value as maximum as possible. So for volume of a box, we know that it is length into breadth into height. By looking on this figure, it is clear that the length of the box is 18 minus 2x, breadth of the box is 18 minus 2x, and the height of the box is x. Try that. For finding the volume, length of the box is equal to 18 minus 2x centimeter. Breadth of the box, again 18 minus 2x centimeter. Then look, it is 18 minus 2x means from this part we are removing x centimeter and from this corner we are removing x centimeter. Then height of the box is equal to x centimeter. This x will be the height of the box. Then we need to find differentiate the expression for volume of the box. Therefore, next write volume of the box. Volume of the box V is equal to length into breadth into height is equal to 18 minus 2x into 18 minus 2x into x. That is, you are getting V as 18 minus 2x into 18 minus 2x into x. 18 into 18, it is 324 into x. 324x minus, then we are getting it is actually 18 minus 2x the whole square. Then it is 36 into 2, 72x. Then into x, 72x square plus 2x into 2x. It is 4x square into x. It is 4x cube. You will get like this. Then we need to find the critical point for this volume because it is the critical point which is making its maximum or minimum. Therefore, we need to find dV by dx. It is equal to 324 minus 144x plus 12x square. Okay, from this expression we can take 12 common. Then you are getting it as 27 minus 12x plus x square. Okay, and we know that, okay, for I'm writing the same thing as x square minus 12x plus 27. Product is 27 and sum is minus 12. Therefore, we can easily factorize this as 12 into x minus 9 into x minus 3. Then for getting the critical point, we need to put dv by dx is equal to 0. dv by dx is equal to 0 implies our x is equal to 9 or x is equal to 3. Then think, can x be 9? We know that our side is, look, from the figure, that is from the square piece, we are removing a square of side x centimeter from each corner. When x is equal to 9, 18 minus 2x is meaningless. Therefore, we cannot take the value x is equal to 9, only x is equal to 3 is admissible. Therefore, we are writing like that. Only x is equal to 3 is admissible. Next, we want to know whether it's a point of maxima or minima. For that, second derivative test. Look, we have the expression for first derivative as, look, dv by dx is 12 into x square minus 12x plus 27. Therefore, differentiate that expression and don't take this product. If you are taking this expression, you have to use product rule. This is easy. Then now, d square v by dx square equal to, differentiate this again, that is 12 into 2x minus 12. Then we got the second order derivative. Then what we have to do is substitute the value for x in this expression. X is equal to 3. Then you are getting 12 into 2 into 3 minus 12. And look, this is 6 minus 12, negative quantity into 12, negative is less than 0. Without any doubt, we can say that. No need to find the actual value. We want to know whether it is positive or negative. It is less than 0. When we are getting second derivative test is saying that when the second derivative is negative, we are getting the point of maxima. Therefore, x is equal to 3 is a point of maxima. Therefore, 3 centimeters should be the side of the square to be cut off so that the volume of the box is maximum. That is, 3 centimeters should be the side of the square to be cut off so that volume of the box is maximum. Okay, students, we have seen some problems based on the concept of local maxima and local minima. And here we are using the idea that for a function, generally it's maximum or minima. That means local maxima and local minima happen at the critical point. Okay, then you have to try these 3 questions as homework. You must do this and we will see in next class. Thank you.